So we've talked about Riemann sums and the left sum, the right sum, midpoint sum, and then we've also talked about the trapezoid sum, how that's separate from Riemann sums, but it does in a similar approximation. And one thing that's important to understand, besides the fact that these sums are all approximations, is what type of approximations are they? In other words, is a right sum going to be an under approximation of the actual value between the curve and the x-axis, or will it be an over approximation? Same thing for a left sum or a trapezoid sum. And so what I'm looking for you to do right now with this worksheet is to kind of discover when a right Riemann sum will be an over approximation and when it will be an under approximation. And then to do the same thing for a left sum and the same thing for a trapezoid sum. And in fact, to do the same thing for a tangent line approximation, which is something we could have done back when we were talking about the derivative, but kind of connects with this issue as well. Because at some point on the exam, they will ask you about these approximations and whether we're looking at an over or an under approximation based off of the information. So on that discovery sheet that you have in front of you, the first item that I ask you to do is to draw some graphs. Okay, I ask you to draw a function which is concave up and increasing, and then concave down and increasing, concave up and decreasing, concave down and decreasing. And so in order to make sure that everybody's on the right page, I wanted to make sure that you have the correct graphs there for the first problem. So you can see behind me, we have our four situations. And if you've drawn these already, fantastic. And if not, hopefully this helps you out with what I'm looking for. As far as a function which is increasing and concave up, well, obviously we're increasing, but we also need the U shape. So in other words, we're looking at like the second half of a U. That would be a function which is increasing and concave up. If we were looking at the first half of the U, that would be a function which is decreasing, but still concave up. All right, so increasing and concave up, that's like our exponential function, and decreasing and concave up, now we're looking at, like, again, the first half of a parabola, if you will, of like an x squared plus 1, except we're stopping when we hit, we're never going to the concave up. If we're looking at increasing and concave down, now we're looking at some kind of logarithmic growth. All right, so our function is going up, obviously, but the rate at which it's increasing is, in fact, decreasing. So it's increasing and concave down. I'm looking for you to have drawn something like this. And then decreasing and concave down would be that section right there. So that's your setup. And now, again, what I'm going to be looking for you to do is to draw rectangles. So make sure you do this discovery sheet with a pencil, because what I'm looking for you to do is, okay, let's look at this one right here. What's going to happen if we draw a bunch of rectangles in which the upper left-hand corner touches the curve? Well, it does seem to give us a general idea of whether this will be an over approximation or an under approximation. Same thing if we were to do a right rectangle. All right, so now the upper right corner is touching the curve. Well, that means something a little bit different. Okay, and same thing if we're doing, say, like a trapezoid. All right, if we draw a bunch of trapezoids, okay, we can tell whether these trapezoids will be an over approximation or an under approximation. There's enough information on those pictures to help us out. So that's what I'm looking for you to do. Draw some left corner rectangles which touch the curve, come up with a conclusion, erase that. Then do the same thing with the right, erase that. Then do the same thing with the trapezoids, and work your way through these four graphs and come up with conclusions as to what needs to be done or what needs to be happening for a right Riemann sum to be an under approximation or an over approximation. Same thing with the left sum, same thing with the trapezoid sum.